So welcome back to another open sources video. This time we will solve the Eternity 2 puzzle, or at least a small version of it. It's a 7 puzzle, and we have 49 pieces. Each piece has 4 sides, which in total we have 8 different colors, plus the black color, which is for the border. Each piece can be rotated. And we want to get this solution here, so such that each piece is connected correctly. And we will use the constraint solver for this. Let's do some imports first. We will also start the Julia session. We will use revise. And I learned that you can use, I think that was, have it in here. You can use include T for revise, so that when you change something in that file, you don't have to include it again. We will have, oh yeah, I should show you the data file. So here we have all the 49 puzzle pieces. This is color 6, color 4, color 8, color 5. 0 is color black, so the border color. So read puzzle from file name. Then iterate over it, but I want to have the ID of the piece in front, so it will be 1, 2, and so on. Can load this file as well. Okay, and then oh yeah, we should want to have the puzzle, which is first zeros, shall be integers, and pieces, and 5, and n pieces will be lengths of lines. So actually use this here as well, and then we will have puzzle I1 equals to I, and puzzle I2 to end equals to parts, and parts is splitting the line, and one can use this, pass it as an integer, so the dot is for broadcasting. We will return the puzzle, create a main function which takes in the f name, the default is Eternity 7, and then we have puzzle equals to read puzzle, and can see whether that works. Unexpected. And okay. that seems to work. Oh, no, it doesn't seem to work. Here should be a I. Okay, perfect. Then getting the rotations. There we will have 18665, 16658, and so on for parts. Get rotations, puzzle, that will be in pieces times 4 and 5 again. Oh, okay, you have to do it like this. And then for I in n pieces, we'll have rotation indices. So what I want to do here is 2, 3, 4, 5, take the index 2, 3, 4, 5, then 3, 4, 5, 2, then 4, 5, 2, and 3, and finally 5, 2, 3, 4. And then for rotation and rotation indices, and then we want to have rotations of oh, we should do it. Okay, just do it like this. So this will be I minus 1 times 4 plus j will be I, and 2 to end will be puzzle I rotation indices. Oh, rotation, of course. Perfect. Let's check the first. 6658, 6586, and 5866. That looks good to me. Then we want to have n pieces here as well, maybe. So size puzzle 1, and we will have a width which is integer of square root of n pieces. The same is for the height here. Okay, and do we need something else? I don't think so. So we can create our jump model. I included jump, right? Yeah. Of C. Use our optimizer. And then we can think about the variables. So one variable which will be the indicator or the piece. So the idea is that every piece here it has a number, which is the first column, well, basically this one here, and they have to be all different. So this is 1, 1, 2, 1, 3, 1, and so on. and the P will indicate which piece is at this position. Then we will have the color, which ranges from to n colors. Oh, that's the one we are missing. I'll explain the U in a moment. And colors is the maximum of puzzle from 2 to end. Maybe do it like this. So this will be the up color. So in this case black, in this case blue. I don't know what that color, what's the name of that color. Okay. Rights, down and left. That looks good. We will optimize M. And maybe we can add our first constraint here, which will be, it should be in a flat array. That's why I use this notation. And status is termination status of M. That starts all the solving compilation process, so it will be relatively slow at the beginning. And oh yeah, we want to do it like here. So for the plotting one, which I will not explain here, we need some arguments. So a file name where we will save it in the end in the images folder. And we need the puzzle, the ID of the piece, or the ID of the pieces, the up, the right, the down, and the left color. So I'll call it solution P, and it all should be an integer. And P. SPU, R is R, D, D, and left, and then plot eternity, puzzle, SP, SPU, SPR, SPD, and SPL. And eternity. That might take a little bit of time for plotting. I think the name is... Oh! Didn't include it here. I'm not sure whether that... Well, it's included in here, so I think it will work. But we should include it in here as well. And so yeah. That's taking quite a while again, hopefully just because it's plotting. So we should basically have destroyed this image. Okay, I think it's writing right now. I don't know what's sometimes so slow, but it will be faster in the end, so I think it should be okay. So exactly, we have this now, so you might be wondering, and we have it, so it's column based, so we just take the first solution basically, setting this to 1, 2, 3, 4, 5 to 49. and it's black because just set everything here to 0 and it fits. So yeah, nothing special to be done there. And so we should probably add the table constraint next. So this is in Constraint Solver version 0.1.2, which I released, I don't know, I think 2 days ago. So what we have to do, right, with, so the color should be fixed, and we can fix it by saying that Pij that's what I actually wanted to do, and left, down, right, and up. So that should be in CS table set of rotations. So the rotations is basically, well, what we generated before, and there we want that if we have the piece, then we want to have the matching upper, right, down, and left one of it. And the rotation at the moment is doesn't matter, so you will probably just take the first one. And then if we run it, it says that we have 49 table constraints now. And yeah, now we have the colors. And yeah, I don't actually know at the moment why we moved the one from there to there now. But it doesn't really matter, so it's okay. So for the other constraints, we need, let's fix the borders first, maybe up and down borders. So for j equals 1 to width, and then we have constraints p up, 1j equals to 0, and height also, right and left. Oh, this should be down. Yeah, maybe copy pasting wasn't the best idea anyway, but so should be the first column should be left 0 and the last column should be right 0. And if we do this now, we have the borders black. Perfect. Next up will be, this should be matching, which matches sometimes already, just randomly. And so for up and down, what do I want to do here? Okay, so basically this should be moving so this is the first row, and the first row should be Okay, give me a second. So we want to have constraint M and P rights of one J should be P. Oh yeah, okay. P. I don't know why I need a for loop here. I don't need it. Okay. P left of 1 and J plus 1, and here we need if J doesn't equal to with, so that this is well defined. And here as well, that doesn't equal to height. And then let's go down, up of I1 and I plus 1, and we need the same for the other one, which I forgot here as well. So this should be height and height. Which gives us this, which looks perfect. Okay, and then we want this should be matching. What's the best way to do that? So this should match with the upper one. This should match with the upper one. So I think we can do for I equals 1 to height minus 1 and J equals 1 to width minus 1, and then constraints M of this should, let's do up first, equal to, oh, let's do it like okay, I have to think. Yeah, so down, and this should be up of I plus 1J, and then we have moving right, so this should be left of ij plus 1. And this will run for a while, and I will come back in a few minutes because I know it will run for a while, and then I will show you how to make it faster. Okay, yeah, I'm back. It took even longer than I expected. I think it was faster when I tried it first. Maybe I changed some constraints in a different way, but yeah. So this is the solved version you see here, and as you can see, you can rotate it, so you can put the 3 here, here, or there, and you will always have this same solution. And that's why we can just put the 3 there, but let's call it start piece. And this is finding the first piece from all the pieces, which I call P, and then it's the one where we count puzzle, maybe I call it I as well. And over that one, let's call that one color. I don't know. When the color is equal to 0, we count it. And if that count equals to 2, it's a corner piece, start piece. And hope that's correct now. And P11 equals start piece, and to be sure, let's print out what the start piece is. So it should be 3, and the start piece is 3. Perfect. And now we should not wait for too long, so I will be back in a second. Yeah, perfect. That took less time, so only, well, less than 4 minutes. And yeah, so it's more than 4 times as fast. So like about 5 times. That's quite okay. All right. See you in the next screen. So I want to thank everyone who supports these videos and my blog posts, which you can see in the description below. And I want to especially thank those 3 patrons which you can see here, because they spent more than $4 per month to keep me running. So if you're interested in more videos or more blog posts, and you really like this content, please consider subscribing, liking, and if you have some money left, also consider to support me on Patreon or on GitHub. Thanks, and see you next time.